have seen API implementations, right? So API implementation, we seen just giving the response. We have not seen how to connect with the database. Without connecting a database, without database application, most of the applications are not useful. Okay, actual data is going to store in a database. Let's see what is a database and a database management system. Yeah, this you might be knowing, but just will just recollect the information. What is database and all stuff.
I'm not that much familiar with the databases and all.
And that's fine. Yeah, that's high level. Later we'll see one by
Sure.
one. Yeah, I'm going to. Yeah, also as most of database is a structured collection. Okay, of any data that is stored and managed in a better way. Okay, it is easy to access, organize, update, and retrieve all the stuff. Okay, that is high level database definition. It's not a standard bookish definition, but it's one of the database definition. Okay, so in the database, right, so there are four main properties. Okay, so let's see those things one by one. So first one is atomicity. Okay, so normally we use the word atomic, atom, atomic, atomicity. Let's see what is that. So atomicity property is basically it guarantees that all the transaction succeed either completely or not. Okay, it's kind of either do it or not do it. No, it's not in between. Okay, I'll take one simple example. Let's say sending a money one person to other person. It's basically two step, right? Two step process, basically deducting from one account and adding to other account, right? That is a two-step process. So when you do a transaction is these two combinedly will call as a transaction. So atomicity is either do it both or you should not do it both. You cannot so make a transaction as deduct from one account and transaction is completed. No, not like that. If you deduct a amount from one account, it should be added to the other account. You are getting? Any question here?
Mhm.
This is a kind of
Yeah.
atomicity. It's a property is atomicity. Okay, so that's why normally we use a commit after running SQL query. Normally we do a commit. Right? Earlier days we used to do commit, but now it's doing automatically. But commit is the one actually doing that. We are making sure that it's done. Okay, second property is consistency. Okay, so in bracket I'm using C just for this simplicity. So consistency is guarantee the database remains in a consistent state before and after the transaction. Okay, so this is basically the correctness of the data. Let's say you updated the bank account. Okay, that's a transaction. When you're doing a transaction, okay, so before completing the transaction and after completing the transaction data should be correct. That is a correctness.
Okay.
And the third one is isolation. So isolation is basically all transaction will happen in isolation. It's isolation basically closed kind of thing. It's right. So that is basically if you are doing a one transaction, it should not affect other transaction. It should allow currently running transactions. It's basically supporting parallel things. Like let's say we are updating one customer account number. At the time, it also should allow to read the account information. That's a kind of thing. When you are updating the transaction, you should not block reading transaction. Okay, so that database should be able to process concurrent transactions. That is all. Next one is durability. So durability is once transaction is completed, that's a permanent in the disk. It's a kind of history. Whenever you're performing a transaction, that transaction should be available always. It should not miss. That is called durability. So in any case, those transactions should not be lost. Even though if system fails, let's say, if system fails, you should have some backup kind of thing. It's basically it's a concept of backup concept, right? One of the, let's say you have a database server. If one database server somehow crashes, your data should not be loose. Okay, there is a durability. These are the four properties of a database. These four will combinedly call as acid, ACID. A for atomicity, C for consistency, I for isolation, D for durability. If you take any database, normally we'll decide or we'll define database basing on these four properties. So relational database, if you say any relational database, that should support all these four properties. When you are using a word relational, nowadays SQL, we are calling a SQL, we compare with NoSQL. When you are saying a SQL database, SQL database, that should support these four properties.
Okay.
Okay, when you say so NoSQL, normally we use a popular words, right? SQL and NoSQL. NoSQL basically non-relational database. So non-relational database may not support all of the these four properties, but it supports at least one. Okay, so
Okay.
basing on these things, you have a lot of NoSQL databases. Okay, so whenever you're thinking about SQL, NoSQL, this is the core definition, differentiation. When you're saying a relational database, it should support ACID properties. NoSQL, so it may not support all. Maybe support three, maybe support one. At least one it should support. Yeah, some cases nowadays, some SQLs. No. Initially they were NoSQL. Later they are all supporting these ACID properties. So that's why maybe you may not call them as NoSQL. Okay, any questions here? Go.
So the major difference between this relational and non-relational databases?
Is only these four properties, nothing else. Only these four properties.
Okay. Okay.
So if it is a relational, it should support these ACID
Oh,
properties.
okay.
If non-relational, may not support all four, but may support three, two, one, like that.
Okay. So is there any difference between data storing,
Data
like
storing, yeah.
storing, data store means
Storing
a
is a different. See, yeah, data storing
table
is a different.
format or
No,
columns?
no. So that is actually logical differentiation, Gauri. Okay, internally database, if use internally low level, it use a data structure.
Mm-hmm.
Okay, some database use a data structure, some store in a file. Okay, so
Okay.
overall some store in a binary. If you are storing in file, right? Okay,
Mm-hmm.
here is, it's not about storing thing here. Okay,
Mm-hmm.
so but the properties.
Mm-hmm.
So storing
Yeah,
is. Mm,
yeah, I got it. These properties.
mhm.
I want to know, is there any difference between both during data save?
Yeah, so that depends on the different types of these things. I'll explain those things. Okay, we are
Okay.
coming. So next slide we have those things. Okay,
Mm-hmm.
yeah.
Okay.
Yeah, so for others, one of my friend is joining from today. He joined actually. His name is Baji, and he just joined.
Hi.
Yeah. Okay.
Hi, Jay.
Yeah. Hi, Baji. We just started. We're discussing about database. We just
Okay.
completed this one. Okay. I'm explaining database types, all the stuff.
Okay.
Yeah. Yeah, I just covered acid properties and I'm explaining about relational and non-relational difference. Yes.
రికార్డింగ్ పెట్టావా చంద్ర అదే?
Yeah, 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 I recorded it.
ఓకే.
Started it. Okay, so let's see. There are different types of data types. As you already knew it. Let's take. So I just explored. These are not only fixed data types. I just explored and I have taken some common, very popular types here. These are not fixed, and there may be more. Okay, these are not fixed things. I just explored and taken by the common use cases, all the stuff. Let's see. And data types. So one of the popular database is a transactional database. Okay, transactional is also called a relational database. Okay, most of the applications will use this relational database. If you take any application, majority will use this relational database. Each transaction is important here. Let's take if you are using any application, you need to log in, right? Most of those things are taking login. For login you need a user. Okay, user is a important, right? Login is a transaction that is important. That's kind of thing. Okay, so these are so common use case. These things will be used mostly in financial domain, and if you are having any relationships like employee employer relationship, okay, student teacher relationship, father son if you have any relationship, those kind of things normally will go for this kind of thing. But importance of relationship. Okay, so in financial domain we should not miss any transactions. That's why we are going for relational database. So banking domain or any loans, all the stuff will go for this relational database, relational or transactional database. Some of the examples, MySQL, Postgres, these are the most popular relational databases. Oracle is there. Okay, SQL Server, those are okay. So when to use, this is the one. So if you are looking for reliable transactions, you don't want to lose any transaction, in that case you will go for this relational or transactional database. So when to avoid, if it is not structured data, if the data is not structured. Okay, in unstructured, maybe not, we cannot say that not structured, it's unstructured. So that in those scenarios we'll go for relational databases. Okay, and there is another database type like a document database. Okay, so here so document data type, it stores in JSON like format. Okay, so each record or each entry is having its own structure. That we call as unstructured. So if we differentiate between transactional and document DB or any NoSQL, so normally people will say SQL is a structured data, NoSQL is unstructured data. That's what normal people will say, right? Here structured is unstructured is basically it's not a standard format. That is whereas in relational database it's always standard. If you are define a schema, data should be in that particular schema only. Whereas in document DB, you no need to be, each record will be in the same structure. Okay, so some of the examples are MongoDB, Elasticsearch. These are the examples for document DB. Okay, so this basically so if you want to quick development, rapid prototyping is one thing. And if your data is unpredictable structure like social media post or logs, right? So logs, these kind of things normally will go for document DB. Okay, when to avoid, so obviously if you are concerned about the structure, you should not go for document DB. So nowadays people are default, they are going to MongoDB, Okay, so for prototyping, and if people are starting, right, they're directly starting with MongoDB. Okay, so but the thing is that if your data is structured, go for relational database. Okay, if you prefer document DB only if you are not aware of the data structure, which format you are getting the data. Okay, any questions here? Okay.
Is any difference like new vector database different? This one,
Sorry, can you repeat the question?
vector vector database.
Yeah, that is coming. That's a different type. I'll show. That is
Uh,
the one kind of database is a vector database. I'll cover that. But
mhm.
here, so we
It
have
will
seen
comes
two.
under the document DB or a different.
That is a different DB. It's not a document DB because here storage, right? We're seeing a JSON like format. Okay,
Mm-hmm.
JSON is basically key value pair, right?
Yes, yes, yes.
Whereas vector DB is not a key value pair. I'll
Mm.
discuss that as well.
Okay, okay.
Okay. And the next one is key value storage. Okay, so another database type is key value store. It's basically a simple and fastest DB. So it's basically it's not a query based. Basically, you give the key, it will give the value. It's not having a relationship, no queries. It's just a lookup. It's a kind of key value store. Examples are Redis. You might have heard about Redis, right? Redis is basically used for cache. Redis or DynamoDB. These are the examples for key value store. Okay, these things normally, these database normally we will use in caching, session management, rate limiting. For these use cases, we will use this one. Okay, when to avoid this one? Basically, if you have a complex queries, so this is not suggestible. Okay, so complex queries, relationship, all those stuff. This is basically cache thing. So Redis is also costly, expensive. So you should reduce the use of this one. Okay, and the next one is GraphDB. Okay, so GraphDB is these GraphDB is in special scenarios. Okay, so relationship between entities and all are entities only basically. Okay, these GraphDBs are used for specific problems. Okay, so examples for this GraphDB is Neo4j. Neo4j is one of the GraphDB. So most popular use case is social networking. In social networking, right, you have a friends, right? So suggested friends, all those things. You'll have a lot of nodes, right? Well, so a person have unlimited friends, all are nodes. So that we'll call as a graph thing. So those kind of scenarios will use a graph DB. Except this nodes kind of thing. So you should not use other scenarios. Okay. And the next one is data warehouse. So if you remember, because in our I'm not sure about you, in our when I was doing my MTech, we have a subject called data warehouse and data mining. At that time this was a very trendy word, but now people are not using that word. All right, so data warehouse and data mining. So data warehouse is basically handling large scale of data and workloads. Okay, so it is good in handling complex queries. Some of the examples are AWS Redshift. So now it is coming Snowflake, right? Everywhere we are talking about Snowflake. Snowflake is one of the example for data warehouse. It handles huge data. Okay, so as it says, we can use in if you have a lot of data, and if you, so lot of data normally will go for analytics purpose only, right? So we'll use for analytics purpose and business insight or business intelligence. For that scenario, we'll go for data warehouse. If you don't have a big data, it's not useful at all. Okay, so it's better go for standard databases. Okay, and so another database type is time series. Okay, so time series is for handling data points of so collected information over time. So like so one of the so examples are sensor readings, monitoring metrics, stock prices. Okay, and so one of the best example is location tracking. Okay, so when you so it's so you will track the location, right? It's over time, right? So best example is location tracking. So when to use, basically location tracking purpose, or if you want to read any metrics. Okay, if you want to read metrics, all the stuff will go for time series database. So when to avoid? So for general purpose applications, this time series DB is not useful. It's only for collecting information. This is basically read only data. Okay, normally once location is update reading, right, will not modify that, right? That's why it's write only. It's not like it's write only data, not read only. It's write only data, and it's not good to update the data. Okay, and another database type is data lake. It's also similar to data warehouse. Okay, so now we are frequently using data lake instead of data warehouse. Right, so data lake is same as data warehouse, but the storage in cheap here. It's like data storage in cheap file storage instead of databases, like Redshift, Snowflake. Okay, so when you are storing in a cheap storage is basically storing in hard disk. Storing in directly in hard disk is easy and cheap, right? Okay, so that's why so data so if you want to retrieve the data from that, you can use query engines. Okay, so example I'll tell. S3 is a storage, and Athena is an engine to retrieve that data using queries. Okay, AWS services S3 and Athena, these are the two examples for data lake. So when to use, basically if cost is a concern, then you go for data lake. Otherwise you go for data warehouse. That's a kind of thing. And if you have a different types of data types. Okay, so when to avoid? So if you want a low latency is basically quick response. If you use a data lake, right, so maybe retrieving the data may be slow, but so cost effective, right? So these are the different points. This is one of the data type. And the next one is vector database. So now everyone is talking about vector database because of this AIML LLM things. Okay, so vector DB is specialized in storing and searching numerical representation of content. If you see that statement is important, numerical representation. Okay, it captures the semantic meaning. So semantic meaning like let's say let's take a king. King is a word. Okay, king is a word, but the semantic meaning of king is basically male, man, ruler, right? These are the semantic meanings of a king word. Like let's take a queen. Queen is also a ruler. Common word is ruler or leader, and female, woman. Okay, these are the semantics. These kind of semantics it will extract, and the semantic meanings, right? These things will take and they'll store as a numerical values. That is the difference. Okay, so examples are pine cone, milvus, quadrant, many are there. Okay, so and when to use, if you are using any AI based systems and RAG kind of systems, you'll go for vector DB. If you don't want a semantic meanings, then it's better not to use vector db. Okay, so these are the common database types I explored and got this information, and the reference link I specified in below, and you may be having more things, but these are the common. Okay, you have any questions here?
Okay.
Okay, fine then. Let's say you have the many databases here, right? How you are going to select a database? Okay, so till now what we are doing, we already application is there, we are using that, but we are now we are getting the let's say you got a chance of designing a system and you want to select the technologies and database, all the stuff. So how we are going to select that? Let's take the criteria here. You have a data model. Okay, data model basically data. Let's take a data. If the data is structured, okay, so you got a data. So data should be either structured and unstructured. There are two things. Let's take if it is structured. If it is structured, and then we have another condition check. So do you need asset properties? That means basically whether your transactions are important. Okay, you need a backup. Okay, you need atomicity, these kind of things. Then you need to um, go for relational database, right? So relational database, there's already there. You can take anything, MySQL, Postgres, anything is fine. This is the criteria. If the data is structured and if you want asset properties, then go for relational database. If data is not structured, if it is unstructured, and if you are looking for text search or query parameters like searching with the regular expression, those kind of things, right? In that scenario, you can go for document db. Okay, so examples of document db, anyway we have seen, right? MongoDB, Elasticsearch. You guys are normally mostly you are from mobile development, right? Front end. That's why you may not get server logs. You may not get the chance to see the server logs. Did you heard about Kibana? Anybody?
No,
Okay. Did you heard about Neuralink logs?
no, Chandra.
Oh, yeah. So maybe you mostly you are from front end, so you're not so that's why you may be not aware of these things. But if you are a back end guys, all the logs we are sending to one common thing. Okay, that normally Kibana also Elasticsearch. Some people will use Elasticsearch. Some people will use Neuralink. This is because all logs, all systems. See, back end will have a multiple systems, right? Okay, let's take a application server, let's say recommendation system, loan system, insurance system. These are different all systems, but all these things logs are they will redirect to one common system. So some people will use Elasticsearch, some people will use Neuralinks, all the stuff. So all logs are different structure. Maybe recommend system may be using a different log format, loan system may be using a different format. Okay, credit card department may be using a different format. All these things will come to the same server database. Okay, so this kind of scenario will go for Elasticsearch, right? So yeah, if you have a rapid database data increase, so finite set of queries, so in that case we'll go for column based db. That column based is normally, as we'll say, is Cassandra, HBase. So column based db basically will not have a relationship. Okay, so that's what so we go for. Okay, And if you are having only append only in write mode, okay, so these kind of things normally we'll call as a time based scenarios. Time based, I think we already discussed, right? Time series DB, it is having a influx database or open tsdb, these are the things. Okay, and if you are having a caching or session management or rate limiting scenario, we'll go for key value is basically, it's not a complex queries. If you give the key, you'll get the response. So examples are redis and memcache, these are very popular examples. And if you are having a social networking and fraud detection, so in this case we'll go for graphdb, and graphdb is neo4j and genus graph. Okay, so these are the database types and how we are going to select the criteria. Any questions here?
Hello.
Yeah.
Typically, even a single system will have all these features, right? Can you use all these?
Single system, single application you are talking about?
Yeah.
Yeah, that's a good point, Gauri. Yeah, see it. So there is no rule, because a single system can use multiple databases. Okay, so multiple database, like see, let's take a banking domain. In banking, for financial transactions, we can go for relational database, whereas for logging, you can go for Elasticsearch, and whereas for location tracking kind of thing, you can go for time based scenario. And if you want analytics, you can go for Cassandra HBase, like that. All systems will use like this. It's not like the single system is going to use only one database. And the criteria, I'll tell one thing. Let's say this is how normally systems works. Let's take a location tracking. Location tracking is a huge data, right? Every second we'll get lot of information. That information they will not directly store to the actual database. They will have a middle, there's a temporary database. Initially they will store in the temporary database. Later they will copy to the original database to make it more efficient. These are all design things. Okay, getting?
Okay.
Yeah, so a system can have multiple databases. Yeah, all systems will have multiple databases. They not, it's not like big applications, right? Big application will have all these at least 2 to 3 databases. One is relational database, another one is for analytics purpose, another one is for a time based thing. And now AI systems came, and definitely they are going to use vector database as well.
Which database?
Vector database, because now people are using all AI systems, right? So definitely they are going to use vector database. Yeah, I think I missed that here. I should have added that if it is a semantics thing. Okay. And so if there is, if acid properties are not required, then you can go take any one of these things. Okay, and that is also if it is a structured data and you don't want acid properties, still you can go for these databases. Any other questions? Okay, let's see. So now these all databases, it's on a backend data store. Let's see how we are going to connect with the database. Okay. So programmatically or with applications, how we are going to connect with the database from our applications. So there comes our ORM, like object relational mapping. It is a ORM concept we'll call. Earlier days, to connect to the database, it's very difficult to connect. Like in 2005 to 2010, in that time, if you want to connect to the database, we need to install drivers, and connecting to the database is a big problem. Okay, so because of this ORM, all these problems got resolved. Okay, let's see what is ORM.
Framework is just,
Yeah, sorry.
it's just a framework, right? Relational.
Yeah, so that is also software. It's a basically, yeah, framework will call. So framework in a different language. So different. Java is having its own framework, and Node.js having its own framework like that. So basically, let's see why ORM. Sorry. So basically, abstraction from SQL. So basically, instead of SQL, you can say from the database, any database. You can write a code, okay, instead of just SQL queries. This avoids so normally you no need to learn SQL queries. So just if you know any language, you can easily connect to the database. So this will help to focus on business logic, not on a database syntax. Even though if you're not aware of database stuff, it's okay. You can connect and you can retrieve the data, all the stuff. Basically helps to focus on business logic. What information you required, how to you just work on what information you required, and retrieving the data. You don't need to focus on how to connect to the database and what are the fields are there, all the stuff. Okay. And database independence. So let's say initially you have written the code for one SQL. Okay, later if you want to migrate to the another database, it's dead easy, just changing the name of the URL of the database. Okay, it will help to so migrate easily. So here the migration is basically not data. Okay, it's changing the database. Initially, let's say you developed an application for MySQL, and so after completing after development, so let's say somehow business team wants to use Postgres instead of MySQL. You no need to change anything, you only need to change database URL, it will work. Okay, that is a advantage of this ORM. And so productivity, obviously you no need to write so common code. So boilerplate is basically common code, so that this tool will take care of that. You can easily it's a fast prototyping. So nowadays it's easy if you know that ORM things. Consistence with the application models. Let's say if you have a different database schemas like data types. Okay, so in that case also it's easy. Let's say Postgres may be having a different data type for string. SQL Server is having a different data type for string, but this will handle ORM will handle that. Okay, so and relationships, so normally one to one, one to many, many to many relationships are there, right? So those relationships are very easy using ORM. Security, one of the biggest advantages why people are moving to ORM is security. See, SQL injection is very common attack. In nowadays also it's very common attack on our applications. Earlier, so before ORMs, SQL injection was very easy, but now people are doing, but it's hard nowadays. It's hard to use SQL injection. Okay. Oh, sorry. Oh, shit. And finally, maintainability is basically we have a cleaner code, object oriented code. It's easy to read and so maintain. Okay, so this is the main advantage of using ORMs. Yeah, without ORMs also you can connect to the database, but yeah, as we discussed, all these properties will help. Any questions here? See, because why I'm spending more time here is you guys are moving to next level. There, people may not ask write code, but the people will ask how we are going to design a system, how we are going to select a technology. Okay, so for that you need to understand so how system works, what are the features, properties of different these things. Okay, so people may ask why you are going for ORM, why can't we use so directly. Okay, you should be able to answer those kind of things. Okay, so instead of going for implementation part, you try to ask more questions on that side. Okay, any questions? Okay, so let's see the location. This is application server. Now let's say the basically high level picture I have drawn. So app server so will connect to the ORM, and ORM will connect to the database. So ORM is between app server and database. Or instead of app server you can use anything, any application. Okay, so it's so before connecting the database, or via ORM will connect to the database. Everything will go via ORM. Okay, so for that mapping is basically if it is a table in the database, in our code that is a class. Okay, if it is a column in the database, that is an attribute in the application code, in our source code, attribute or property, whatever you call it. Okay, that's variable name. And the row in the database is an object in the code. This is the main mapping. You're getting? Table name is a class here. Schema is a class here. Let's say if you are having a user table, and user table is having a username and email. If table is having a two fields, two columns, table is having a two columns. One is a name, another one is email. In the class scenario, we'll have a class of user, and in that class properties are one is name, another one is email. Okay, and the column is basically name is one attribute, email is another attribute. And user object, let's say customer one is a one object that will call as a row. Got it? Any questions here? Clear, right? Okay, so yeah, so let's see the demo. So I'll show the code here. I already created a code to save some time. This is in Python. Okay, in Python we are using this one. So in Python, so ORM very popular ORM package is SQL Alchemy. Here we have that. There are other things as well, but it's a very popular and stable package. So we are going to use that one.
చంద్ర ఒక
Yeah.
డౌట్
Yeah.
ఇప్పుడు జాంగో ఫ్లాస్క్ ఫాస్ట్ ఏపీఐ అప్లికేషన్ డెవలప్ చేసేప్పుడు కూడా విల్ యూజ్ ద సేమ్ ఓఆర్ఎం
Yeah. So it's not mandatory, but it's a popular one. That's why we are going with SQL Alchemy. Instead of SQL Alchemy, you can go for any other Python ORM package.
ఓకే జనరల్లీ విల్ యూజ్
Yeah. So that's a stable one itself. That's why.
ఓకే
Okay. So now let's say I just forget about dependencies first. Well, let's take this line number 7 to line number 12. Okay, I want to create a table of users. Table name is users, and that column table is having a 3 columns: ID, name, email. Okay, this is the meaning of that. So here that I am taking as a user is here a class name, and so this is the syntax basically. This is syntax. Table name we need to specify like this: underscore table name is equal to users. This is the in database it creates a table name as users. Okay, and since the table is having a columns, basically ID, name, email. ID is a integer and it's a primary key. I'm saying this is a primary key, and name is a column. It's a data type is string. Email is a column. Data type is string. Any questions here? This is how we are in the database. It will create a table name is users with the columns ID, name, email. That is what we are writing here. Okay.
Okay, and here ID, can we do auto increment?
Yeah, that is also there. I think here we can by default it will go, but we have an auto increment thing. Yeah, we can by default it will take.
Okay.
But let's see. That's why ID is standard for that. I think why auto increment is not coming. Should be there actually.
Yeah, whether we need to input any other. Okay.
No. Auto increment should be there. Why it's not coming? Yeah, here we are specifying primary key, right? Like that should come auto increment. Yeah, there should be other field, but we can do that. Okay, okay. Any other questions? So here table name is users and it is having a 3 columns: ID, name, email. This is just a Python utility. Just will ignore for now. See, we are saying to the database and create a table, and the table name is users, and the column names are ID, name, email. How we are going to interact with the database? For that, actually there are multiple steps. See here, so we need to import one method as a create engine from SQL Alchemy. Okay, from SQL Alchemy we are creating a method. We are importing a method create engine. For that create engine we need to specify database. Okay, here I am using SQLite. That's why I am specifying this format. Instead of this one, you can use any database. MySQL, we have a MySQL database and URL, right? So that you can use here, or SQL Server. Anything you can use here. Now we are creating an engine. After creating an engine, this line is basically line number 19. Will create tables. Okay, line number 19 will create tables. How this will create a table? Basically this will map to this base. See, base, it's mapping. We inherited properties from this one. That's base is so the declarative method, that is from SQL Alchemy. Okay, so here with this line it is connecting to this database and creating a tables.
So yeah, Chandu, here that engine you passed path, right? SQLite DemoDB. So SQLite means if you are using SQLite, then we need to pass SQLite, and if you are using NoSQL, then NoSQL.
Right. Yeah. So that may be. So I have another one. Maybe if you want, I'll show that one. Maybe.
So it should be in the same folder, that database.
No. It should be anywhere. That path is basically, say, SQLite is a lightweight file thing, but normally that's why I kept here. But you can give anything, any path here. This is basically path of the database.
Okay, so but it should start with like this:
Yeah,
escalate three slash
right,
slash.
right.
And
The
then,
escalate we are specifying to that engine SQL alchemy. Okay, saying that
okay.
this is a SQLite database.
Okay, okay, okay.
Otherwise, if it is MySQL, it should be like this.
And after three slashes, we need to specify actual
Yeah,
path.
that is a syntax actually. That's syntax. You need to
Okay,
follow that.
okay, okay.
Okay, that's basically uh, URL of the database. If you want to
Okay.
connect, right, this MySQL host name, username, password, then database, right? That's the format.
Okay, okay.
Yeah, so like that.
So if it has a password, username, password, then here only we need to pass the
Right, right.
username.
Here only we need to pass. I'll show that. I'll show that.
Okay, okay, okay,
Maybe that is somewhere in my thing. I'll
okay.
show that. Okay. That's what I told you, right? In ORM properties, you just change this one with database.
Okay,
If you're having a MySQL, normally MySQL, the, this MySQL specifying so that SQL Alchemy install drivers of MySQL.
okay, okay.
Okay, then host name, that is basically IP address. Then username, password, something is there. Username colon password is the one. Normally it's one, and slash db name. This is how normally syntax.
Okay.
Yeah. Okay, now I'm using SQLite thing. So here basically we are taking a database name and tables. These tables we are taking from here. There is only one table. After this one, whenever after creating a database, if you want to connect to the database, right? So this is session maker. This session maker will basically connect to the database, and it will give a new session. Using that session, you can insert, delete, update, all the stuff. Okay, so let's say insert user. This is a simple Python method. This one is a simple Python method. Until this one, let's take oh sorry, this is a simple Python method. Even though name is insert user, it's basically taking name and email, right? We are printing that thing. And if you want to connect to the database, basically first we create a class or instance of that. This is a row. We are creating a, this is a class, right? User, it's having a name and email. These are two fields. We are creating that class, and that one we are adding to the session and committing this to that session. That means it will add that one and it will update the database. That's what. Okay, this session is basically creating, we are created a session here. That session is to connect to the database. For that we have a table name is users is a table name, and properties that values are name and email, right? Any questions here?
చంద్ర అది యూజర్ అనేది మోడల్ క్లాస్
ఇదా ఇది ఆల్రెడీ క్లాస్ మనకు డిఫైన్ చేసాం కదా.
ఓకే ఓకే
Guys, you are following?
Yeah.
Others, Gauri,
Yes.
yeah. This is a simple thing. Let's say let me run this one so that you can insert. Yeah, I think I already have these things. Let's comment all the stuff. So I'm inserting two users. Okay, username and email. Let's query those things as well. Let me run this one. Where are you? We have testing demo, sorry. is the file name? ORM demo. P3 ORM demo. Let's see. Okay. See, inserted user ID is 1, name is Chandu, email is chandu@chandudev.com. Okay. User 2, next one you created Chandra, email this one, user ID. See, automatically it is incrementing ID 1, ID 2, because mostly if you say ID, it automatically increments, and we are printing those two things, right? Have any questions here? Is this clear?
Yeah, it's clear.
Yeah, others, Gauri, Shiva.
Yes, go ahead.
Okay, so let's say if you want to connect to the database, this is SQLite, SQLite 3, I think demo. Yeah, let's see here. I connected here. Let's see tables. See, table name is users. Okay, so here you can see select star from users. I connected to the SQLite database and I can see there, same format. Table name is users. So if you want to table name instead of users, if you want some other thing, that is also fine. You can change that here, maybe users demo, something like this. You can change here, right? Let's do it that one. Maybe I'll control Z. Same result, but let's see that. Let's connect to that SQL database. Did you see the difference? Earlier the table name is users. Now we change the table name to users underscore demo. But, right? So if you use normal instead of ORM, if you use some other thing, you need to write a SQL query. You need to execute that SQL query. Then only we'll create the table. Here with the ORM, we just changing the name and it works. Let's start from users underscore demo. Same data, right? So this is for insertion. If you know the insertion, and let's say how to retrieve the data. Anyway, we printed it. So for retrieving data, basically we need to apply a filter. Those filters are conditions, like where clause. Let's say here, you guys are aware of where clause, right? It's a simple SQL queries. Gauri,
Yes.
Shiva, Anand. Yeah. So just let's like select star from users where ID is equal to 1, right? This we all know. This is retrieving all the information. Select star from users. So that one here in our code is session query. We are passing query. The table is user and retrieve all the information. This is similar to in the backend select star from users. That's it. Line number 34 is equivalent to line number 35 query in code. You're getting? Okay. Let's say if you want to filter it out. Let's say if you want to select something like where ID is equal to 1. That becomes like this. Let me take this. Instead of I'll modify this one something like this. Users by ID. Query user by ID. I'll pass ID. Okay, ID will get user ID. This user ID, maybe you can take something like this. id is equal to user id.
So dot first means it will give first element.
Okay, I'll tell that one. I'll tell that one. That is a simple thing. Yeah, why we are using. First, let's say this is equivalent to whatever the query line number 42 is equivalent to select star from users where id is equal to user id. Okay. So let's say the filter, why we are using dot first. So normally not required, but somehow because of our logical mistakes, this filter may give multiple results. Okay, this query may give multiple results. I think more than one record. So that's why you just take first record of that list. That's why we are getting this. You got my point? Yeah, in this case obviously user id is unique, but in production, right, in we don't know. So in production, instead of retrieving id, you may use name. Let's say name. Okay, so names may be repeating, right? So those scenario, so if you want, that is all logical handling, how we are going to handling the logic. You got it? Any questions? So here query by id, let's take query by id, let's take 2. Let's run this. Hey sir, first we need to run this p3. Yeah. All users 1 2 3 4. Okay, did you get the answer, guys? What we have done here, we created 2 users because 2 times we ran, that's why 4 are there. Let me comment out this. If I run this one, so now we will see that. Okay, I'm passing id too, that's why I'm getting this information. Got it? Any questions here? So here the filter by, you can use any properties. Instead of name, email, you can use any available property, any available column, id, name, anything you can use. Okay, and any questions?
Clear, Chandra.
Okay, good. So let's say so because we have when you are talking about database, right, we should discuss about CRUD operations. CRUD is basically, there are 4 operations, right? Create, read, update, and delete. Whatever we have done now is insert is basically create, retrieve, query users is basically read. We completed CR, create and read. Let's see update. For updating, basically already record is there, right? Data is there, we need to update it. For that, you first read that record user and you just change the values. But now this is an object, right? In the object we can assign the values for those properties directly like this, right? And you commit that session, so that will update the record. I'll run that now. And delete is basically you just retrieve that record and session dot delete and pass that whatever the information you are deleting, it will delete. You got it? Let me run these remaining things so that you will understand. Okay, see, there are 4 users, all users 1 2 3 4. We are deleting user id 2, we deleted, and remaining users are 1 3 4, we deleted user. Okay, any questions? Okay, so if not, maybe I'll stop here for today. Okay, so in the next class I'll discuss with APIs. Okay, how to interact with the database using APIs.